Exam tips and techniques. In this nugget, I'm going to try and help you kind of get in the right mindset for the exam. And what I'm going to do is present some different scenarios and questions, kind of walk you through them, and point out what I think are the criteria that you really need to focus on. Now, I do want to emphasize that nothing I'm going to present here is real live exam content, but I think what I'm kind of offer to you here really does represent the spirit of the exams. It really should help you get into the right mindset. Here's the first scenario, which has to do with DHCP. Now, let's say that your main office building currently is located across several floors. So you've got a building with multiple different floors. You've got a data center on one floor, and part of that data center is a Windows Server 2012 failover cluster. One of the things that cluster contains is a DHCP server resource, meaning you have a clustered DHCP server. Now, right now, all of your client computers receive their IP addresses from that, and they all receive it from a particular single subnet. Now, what you're planning to do is implement a change so that each floor of your building is going to have a separate subnet. So that's one floor, two floors, and three floors. So each of these is now going to have a separate subnet, and they're all going to be connected together via routers on each floor. Now, you already know that you need to set up separate subnets in the DHCP server, but you want to make sure that each of your client computers is able to receive addresses from those DHCP servers. What do you need to do? And this is one of those scenarios that you'll often find on a certification exam where you see a lot of words like failover cluster and DHCP, and your mind starts to wander down that path of I need to be thinking about DHCP, DHCP, DHCP. But really, this isn't a Windows Server question. You know, if the goal is you need to recommend changes to your DHCP infrastructure so that all your client computers can be assured of getting their IP configuration from your DHCP cluster, well, the real trick here is to focus on that keyword, changes to the DHCP infrastructure. You simply need to make sure that all of your routers are configured to accept DHCP requests and forward them off to the appropriate server. Keep in mind, DHCP broadcast requests, when a client needs an IP address, it broadcasts that only on its local subnet. The router is responsible for picking it up and forwarding it or relaying it off to the actual DHCP server. The server will send that response back to the router, which will then forward it to the client, and that's how the client gets its address. So there's no changes to Windows Server here just because you're breaking your things across multiple subnets. You configure your subnets on the DHCP server and make sure that the routing infrastructure is set up to forward those requests. Here's another scenario that can be a little tricky. Let's say that you're starting here. This is your existing environment. You have a single domain named company.com, and all of your clients belong to that domain. All of the servers that are your domain controllers also run DNS, and they all run Windows Server 2012. So as it sits, everything works fine. Your client computers can find every single computer name they need in the company.com DNS zone because all of your DNS servers are essentially authoritative for that zone. Now let's bring something new into it. You want to deploy a child domain, ops.company.com. That is going to require some domain controllers, and they are going to be DNS servers. By default, if you're using those Active Directory integrated zones, they're only going to be authoritative for the ops.company.com domain. Now let's say you're going to push some of these guys off to a branch office. Now, what you want to do is ensure that everybody in the operations department, so that's all the folks over in this new setup, are able to access the servers in the original company.com domain. What do you need to do to make that happen? Well, you might say, I need to create a zone delegation over here, but that's actually not true. That's not correct because this server is never going to contain names for company.com. You could just set up a bunch of CNAME records over here. In other words, figure out what servers you have in the other domain and make sure that they're listed over here. But that's not really the right answer either because it kind of breaks down the whole dynamic nature of things. You start creating manual records and you start having to manually maintain them. Now, you see, this is where there's a difference between the Active Directory domains, .company.com and ops.company.com, and the DNS zones that support those. A DNS server is perfectly capable of keeping zones for which it is not authoritative. It's perfectly capable, in other words, of keeping the records for a zone that it isn't a domain controller for. In other words, all you need to do is change the replication scope of the company.com DNS zone so that copies of it are also stored on the ops.company.com domain controllers or DNS servers. So you're simply changing the replication scope of this information so that Active Directory can replicate it down to other domain controllers. That way, when these guys query this domain server or DNS server, they've got all the records they need right there. A lot of these scenarios, like this third one we'll cover, really just require you to stop for a second and think. Now, for this one, I'm going to lay out the scenario, and then I'm going to offer you some options and let you think about why each one might or might not work. So here's the scenario to start with. This is what you've got to begin with. This is about DHCP again. You've got a single server named Server 1 that runs the DHCP role. It does run Windows Server 2012, and currently all of your client computers receive their DHCP information from it. You've decided to add another server named Server 2, which also runs Windows Server 2012. You want to make sure that your client computers can all continue to receive an IP address. You want to make sure that they're still getting the same subnets and everything else, but you want to make sure that even if one server fails, they can continue to get the same addresses. So how would you do that? And let me present you with some options. Would you set this up using network load balancing? Would you maybe configure it as failover in the DHCP scope? Would you maybe create a DHCP failover cluster? Or would you perhaps create a split scope? Now, one of the things that can kind of come into here is exactly how much failover. So I'm going to throw another thing in there. You want to make sure that clients can continue to receive DHCP addresses even if one of these servers completely fails, meaning its disks and everything. Now, right there, that should tell you that clustering is out. Now, as we talked about in the nugget on DHCP, failover clustering does not provide fault tolerance for disk subsystems. So now let's look at NLB. If we set up a network load balancing cluster, then clients are going to be sort of statistically balanced, almost randomly accessed between these two DHCP servers. DHCP servers, by default, don't talk to each other. Now that means if these two servers are configured with identical scopes, then a client coming over here might get address 5, and a client coming over here might also get address 5, because these two servers don't know that the other one has handed it out. So NLB is not designed for situations where the servers aren't coordinating their activity in some fashion, which DHCP doesn't, so NLB is kind of out of the question. Now, a split scope is not a bad solution, and that, if you remember, is where we hand out a range to each server. So this will get 5 to 10, and this one will get 50 to 60. The problem here is because you're splitting your scope between the two, each server has exactly half the IP address capacity that it did if it was just the single server. So now if a single server goes down, you might not be able to fulfill all your client requests because the missing server has taken half of your IP addresses with it. So it's certainly doable, but it's not the best option. And that leaves us with failover DHCP. Now, under failover DHCP, if you remember, we're going to configure each server to have the complete range, and they are going to talk to one another. Now, there's no need to put network load balancing in front of this. The clients will hit whichever server they hit. These guys will probably hit this one because it's on their subnet, and these guys will probably hit that one because it's on their subnet. But so long as your router is configured to forward requests between subnets, if this one goes down, the guys over here can still talk to over here. Wow, this looks like a football playfield. So DHCP failover is probably the best answer. Although some of the other ones might do it, that one gives us the best chance of really meeting the criteria with the fewest potential downsides. Okay, here's our next scenario. Let's say that you've set up a direct access server on your network. Now, your outside clients, the folks who are wandering around in hotel rooms and out in the field, they're going to use various devices. Maybe this is a cool new Surface Pro tablet device to use direct access to get into your network. Okay, that's fine. Now, your network has a smart firewall, a firewall that's doing a lot of antivirus and filtering and things like that. Your network security policy says that whenever a client computer connects to the corporate network from the internet, all of the traffic destined for the internet must be routed through the corporate network to take advantage of those firewall features. So you need to recommend a solution so that the planned direct access deployment changes can meet that security policy. So what should you do? Would you, for example, set the ISOTAP state to enabled? Probably not. All that's going to do is configure some tunneling options. Would you maybe enable split tunneling? And this is where you really have to know your terminology. As we talked about in the direct access nugget, split tunneling means that any access to corporate resources go through direct access, but any external access doesn't. You actually want the opposite of that, which is forced tunneling, meaning any access to public resources goes into the direct access server and then right back out the firewall. And it seems like a waste, and as we talked about on the nugget, it kind of is a waste of bandwidth, but the trade-off is you're able to meet your corporate security policy that way. So this is kind of one of those instances where a question might give you competing, kind of conflicting priorities. You might think, I never want to use forced tunneling because it's such a waste of bandwidth. But when it's the right answer to meet a security policy and you don't actually have a stated requirement to conserve bandwidth, then it turns out it's probably the right thing to do. Sometimes it's worth spending your time, your exam time, in actually constructing a little diagram of what a particular question is asking you. For example, just kind of close your eyes and I'm going to read you something. I'm going to show you the difference and how much easier the question becomes once we draw it out. So close your eyes. I'm going to pretend that you have an office with an Active Directory domain. Now your main office has got a server that runs Windows Server 2012 and the routing and remote access role. That RRAS role is used to accept incoming SSTP-based VPN connections from a bunch of client computers, folks wandering around in the field and hotel rooms who are running Windows 7. Now, your company plans to open a new office. Maybe it's a temporary office. So you're kind of trying to stay on a budget here. Now that's going to have a server as well, and it will also be running Windows Server 2012, and you can install whatever roles you want. It's going to have a half dozen or so client computers, maybe a dozen client computers, and it will be connected to the internet. You need to come up with a way for the users in that temporary office to access the resources in the main office. Now, again, there's a lot of ways you could go about doing this. Let's say, would you maybe install a Connection Manager Administration Kit package on each of your client computers at the temporary office? Or would you maybe install the RRAS role on the server at the temporary office? Would you maybe install it and configure demand dial interfaces on there? So, all right, open your eyes now. Here's the situation. This is your main office, right? You've got an RRAS server connected through a firewall to the internet. Here's your new temporary office, has a server, has some client computers, and is connected to the internet. And if you just kind of walk through some of those possible options on the drawing, the right one almost jumps off the page. So the first thing I suggested was using the Connection Manager Administration Kit to install a VPN connection on each of these so that they would go out to the internet and through to your VPN server. That would certainly work. Is it the best solution? Is it the easiest solution? Well, maybe not. The second one I suggested was to put RRAS over here. And if you did that, you could configure a site-to-site VPN tunnel that would allow all of these guys to tunnel through it over into the corporate network. In other words, the real criteria here is, are you going to configure a bunch of machines or one machine? Because in my world, configuring one machine is always less work. Now, you've got a couple of ways you could set that up. For example, you could configure this with RRAS, and you could create a permanent site-to-site link or a demand dial site-to-site link. Well, which one are you going to do? It kind of depends a little bit. Keep in mind that you're probably not paying by the kilobyte for that internet connection, and having the permanent site-to-site connection means these guys can always get over to here whenever they need to without waiting for a connection to be brought up. I would say, all things being equal, that's a better solution than a demand dial interface where the connection isn't up all the time, and every single time somebody wants to access something at the main office, they have to wait a moment while that connection comes up. Now, I could also imagine that maybe over here you've got a limited number of VPN slots, so having this guy in with a persistent connection reserves his slot. On the other hand, if you did demand dial, then there might be an occasion when there wasn't a slot available and these guys would not be able to get over there. So I would say that the RRAS plus the site-to-site link is probably the best solution, although all of the options I outlined kind of would accomplish the basic stated goal. Our next scenario is about network access protection. Now let's say that all of your local computers on your network all receive a DHCP address from a Windows Server 2012 DHCP server. You've also got some clients that are connecting via a virtual private network, and they use machines that are not joined to the domain. However, when they connect via VPN, they still get a DHCP address from the same Windows Server 2012 computer. You want to make sure that all of your client computers who are connecting have an up-to-date antivirus. You just want to verify that that's there. Anybody who has an out-of-date antivirus definition or engine should be warned with some sort of pop-up message, but should still be allowed to connect even if they're outdated. Now, you need to pick a network access protection enforcement method. Some of the ones we talked about in that nugget were VPN enforcement. We also talked about DHCP enforcement. We talked about IPsec enforcement, and we talked about 802.1x enforcement. Now, the fact that we've got folks coming in over a VPN means we're not going to be able to use 802.1x because that's only going to be deployable in your infrastructure devices. So that's out of the question. Now, we can't use VPN because we want this to work for locally connected clients who aren't coming in via a VPN. So even though we have some who are, not all of them are. We can't use IPsec very easily because not all of our client computers are joined to the domain. So getting the certificates deployed that IPsec requires is kind of difficult. That leaves us with DHCP. So sometimes this is really just a matter of looking at the criteria that you've been given and doing a simple process of elimination. Look at each one, and this is the first thing I do when I kind of go through these lists. I look at each possible answer, and then I look back at the criteria to see if that answer isn't just completely ruled out. It does require you to know all of these different techniques, but we've covered all of those. So as long as you have them in your mind, you should be able to eliminate the ones that aren't possible, and whatever's left is probably the answer. Sometimes the right answer is really just a matter of knowing how the technology works. Now, let's say that you've created a bunch of generalized, general-purpose Windows Server 2012 images, virtual machine images. You've put those out there so that authorized users in your environment can use the System Center Virtual Machine Manager self-service portal to provision, to spin up their own virtual machines based on those images. Now, in addition to including those images in the VMM library, you've also got to identify some VMM components that are going to be associated with the image. What would you specify? And really, this is a matter of just understanding, and this is something we talked about in the nugget on VMM, that an image has got to have a couple of things associated with it. A hardware profile, which tells VMM what type of virtual machine hardware that the image is relying on. So how many virtual processors, how much virtual RAM, stuff like that. You don't want that stuff specified by a self-service person or they're going to ask for the world. You want to specify the hardware configuration that goes with your images. You're also going to have to specify a host profile, meaning what type of host machine does that image need to be hosted on? Does it need to be 64-bit? How much memory does it need? What hypervisor? Notice that nothing here says Hyper-V. That's part of this, is what hypervisor are those Windows Server 2012 images built to run on? Is it vSphere? Is it Citrix? Is it Microsoft Hyper-V? So those are all things that it's just kind of a matter of knowing how the stuff works, and we've certainly walked through a lot of that, and maybe spending a little bit of time practicing with it in your own lab, at home, or at work, so that you can just kind of really see all those pieces come together. It's obviously one thing for me to show you, but it definitely sticks a lot more if you take a little time and practice it on your own so that it can really sink in and kind of become second nature. That's especially true when it comes to some of the different tools and utilities that we've discussed throughout this series of nuggets. For example, here's another scenario. Let's say that your network has got a bunch of servers that run Windows Server 2003, and you've got a bunch that maybe run 2008 R2, and a bunch of servers that run 2008. You plan to upgrade all of these things to Windows Server 2012. Your company hit the lottery, it's got a bunch of spare money, and you just can't wait to give it to Microsoft. So you've got to create a report. You've got to determine which servers run applications that can be upgraded. So you kind of got to have your application compatibility report. Which servers have hardware capable of running Server 2012, because obviously it's changed a little bit in terms of system requirements since 2003. And which servers are suitable to be converted to virtual machines instead of being migrated to a physical machine, so that you can get a little bit of consolidation. What tool have we talked about that would do that for you? Some of your choices might be the Application Compatibility Toolkit, the Windows Server Migration Toolkit, the Assessment and Planning Toolkit, so the Microsoft Assessment and Planning Toolkit, or the Microsoft Deployment Toolkit. Lots of toolkits, but at the end of the day, you can do a process of elimination here too. The Microsoft Deployment Toolkit is for actually deploying. That presumes you have already figured all of this out. The migration tools, again, are for actually migrating. Presumes you've already figured out what can be migrated. Application Compatibility Toolkit sounds interesting, but that really is not going to do anything about the hardware or the virtualization consolidation piece. So that's just kind of there to throw you off base. What's that leave us with? Well, it leaves us with the Microsoft Assessment and Planning Toolkit. That's not only going to look at your applications, but also look at the hardware involved and give you an idea based on current performance load, which machines might be eligible or good candidates for moving into a virtual machine and consolidating them on a host. So again, it's knowing what tools are there, knowing what they do, and working through the process of elimination so that you can figure out which one is the right answer. Here's a fun one. Let's say that you're going to deploy a bunch of new servers, physical or virtual, doesn't really matter, over the next few months. They're all going to run Windows Server 2012. Now, you plan to do this with Windows Deployment Services, WDS. So one of the things you're going to have to do at the beginning is create an image that can be deployed to these machines. This is almost like a puzzle. Here's the 4 different types of servers you plan to deploy: file servers, web servers, domain controllers, and infrastructure. Now, your file and DCs are going to get a full install of Windows Server 2012, whereas your web and infrastructure servers are just going to get a server core install. Each of those different types of servers has different server roles you want to have on them: DFS, IIS, Active Directory Domain Services, and DNS. And then your infrastructure, you're going to have DNS and WINS on there. You might also have DHCP on there as well. We can toss that in. So, given all these differences, what is the minimum number of server operating system images, deployment images, that you need to create? Now, play the Jeopardy theme in your mind for a second while you think about this. And the answer is just 1. Keep in mind that the operating system image is one of the things you're going to have to patch and maintain over time. For example, if you were to set up a file server image, one that's specific to file servers, that has the full install of 2012 and DFS, when patches come out, you're going to have to patch that. If you do the same thing for each of these, install a full ready-to-go image, that's 4 images you've got to patch over time. And you're going to have to continually do that so that as you deploy new servers, they remain patched. On the other hand, if you just deploy one image that has, let's say, server core, part of WDS lets you specify roles and features. Well, the GUI is just a feature. So server core plus the full feature plus whatever roles you need on each one gives you each of your 4 server types. But you still only have to maintain one OS image. So it's really a question, especially for this one, getting out of that old ghost mentality where an image is only good for one thing, and remembering that Windows Deployment Services is designed to deploy things in layers. You're going to have your base OS image, and then you're going to layer roles and features on top of that. So you get your base OS image, whatever features you want, like the GUI for full if you don't want a core install. Then you start layering on roles on top of that. Maybe layer on a few applications on top of that. And the WDS automates all of that. I mean, it's not like it's any harder. You're still only really pushing one button to make it all happen, but you get a lot less maintenance, which is what makes that a better answer. Okay, last scenario. Let's say that your company currently has a main office that's got a bunch of servers and a bunch of users. One of those servers is a file server named Server 1, and it contains a bunch of files that pretty much every user needs to get to every single day. Reports, spreadsheets, stuff like that. The company plans to open a new branch office. This is going to be connected to the internet, but it's only going to have client computers. You want to implement some sort of solution so that you can reduce the amount of bandwidth going over that branch office's network connection, because all of these users are going to need to get to all of those big files several times a day. What's the best answer? Well, again, it's a matter of really working through the criteria. For example, let's say, would you install the branch cache for network files role service on server 1 and then configure the client computers to use the branch cache in hosted cache mode? You got to think about that for a second. What you're saying is, I'm going to tell this one that it's going to run the branch cache service, network file service, and I want these guys to use a cache that's hosted someplace. Well, where's it going to be hosted? Nowhere. There's no servers at that office, so that's not even a good answer. Okay, so let's do another one. How about if you configure the offline settings of the shared folder over here? So these guys each wind up individually caching all of those files. Of course, the downside is they're not actually offline, are they? They think they're online, so they're never really going to cache that. See, offline literally means offline, severed from the network. The offline files feature is designed to help someone who's 30,000 feet above the Earth's surface on an airplane so they can get to stuff. If they're connected to the network and they can get over here, they're going to do it. So that's not a good answer either. What about this? What if we enabled branch cache over here? So we turned on the branch cache for network files role service, and we configured the client computers to use branch cache, but in distributed mode. You like that better? Because I do. Because distributed mode means these individual client computers each act as a kind of file server for each other. And if this guy is the first one to get the report, he's going to pull it over, but he's going to keep a copy that everyone else can look at. And if he's the next one to pull another file, he'll have that file and everyone else will look at him. That's exactly what branch cache distributed mode is designed to do. So again, this is really just a question of process of elimination. Knowing what each of these little features does and deciding whether or not that's contraindicated by something that's presented to you in the scenario. Well, there you go. Hopefully some of those scenarios will really strike home with you and help kind of relate all the things we've covered in the preceding nuggets to the idea of making kind of distinguishing decisions for the exam itself. If you can kind of keep these scenarios in mind and learn to pick out the key bits of a particular scenario and really apply it to the decision making, and then think about all the features and techniques that we've covered in the preceding nuggets, well, you should be ready to tackle that exam. I hope this has been informative for you, and I'd like to thank you for viewing.